Alrighty, you are good to proceed.
All right, thank you. Good morning, everyone. Thank you all for joining. We greatly appreciate the engagement. I'm Craig Jeter. I'm the president of East Carolina University's AIS chapter. And today we are privileged to have a very special guest speaker with us today, that being Dr. Shabrelu. Dr. Shabrelu has over 20 years of experience within the security space. He currently holds the position of Director of Security Architecture at Red Hat. And today he'll be talking about threat modeling through cloud services. This should be a very insightful and engaging session. And with that being said, I will now be handing over to Dr. Shabrelu.
Thanks, Craig. Do you guys hear me okay? Do you hear me okay?
Yes.
Yes.
Just making sure. Good morning, everyone. Thanks for joining the Threat Modeling Cloud Services session. If you have any questions in the middle of my presentation, please go ahead and unmute yourself and ask a question, or basically type the question in the chat window. If someone could read that out for me, or you don't need to. My point is, we need to make this an interactive and not necessarily wait until the last few minutes to ask the questions. If there is a question that you don't want to wait until the end, please go ahead and ask. Okay, so with that, I'm going to enter the full presentation mode. Hopefully that is still okay. As Craig said, I've been with Red Hat for about 9 years, and I've been with Cisco for 12, 13 years before that. I'm also the current president of Cloud Security Alliance Triangle Chapter. Here, it's in the Triangle area. So today's presentation is on cloud threat modeling, cloud services, or threat modeling in general, which we could use any type of security framework to for performing threat modeling. But I'm going to use the Cloud Security Alliance CSA's CCM, Cloud Controls Matrix, as a control framework. And I published the similar, I wrote a paper and published on Threat Modeling Connect using NIST cybersecurity framework as well. But today we'll focus on the control CCM, Cloud Controls Matrix. I'm going to spend a few minutes at the beginning to just to give a very high level introduction of what threat modeling is. And then I'm going to spend a few minutes talking about Cloud Controls Matrix, also called CCM, which has been published at least 10 years back by Cloud Security Alliance, CSA, global organization, which is a nonprofit organization in the area of cloud security research. And then I'm going to walk you through the crosswalk between STRIDE, or threat classification. I'm going to go over what STRIDE means in a minute, and the controls. So threats versus controls. And then I'm going to spend about 15 minutes or 20 minutes at the end, depending on how many questions you have, meanwhile, to provide a demo on using a threat modeling tool, which I developed using a simple spreadsheet. Okay, so what is threat modeling? So threat modeling is, we all do threat modeling in different ways, right? There are many ways to think about threat modeling, but for the definition's sake, it is defined as a structured and repeatable way to identify threats and come up with a way to mitigate those threats. Okay. Sometimes we may not be able to mitigate those threats and we just accept the risk. But as long as there is a way to mitigate the threat, we try to either implement or inherit to reduce the risk. Okay. So why perform threat modeling? If you do not understand what threats might be applicable, or what threats might be there in the system, whether it is you're developing a web application or a platform or some kind of a complicated network infrastructure, we cannot build secure systems, whether it is an application or infrastructure, whatever it is. If you do not understand your weaknesses, you cannot develop as a strong individual. So threat modeling is used to, in a model system, identify threats, analyze vulnerabilities, what could go wrong, and come up with potential solutions or security controls in our case, as the case may be, to mitigate those risks. Okay, so the same thing that I just explained in a graphic, threat modeling process is basically asking for questions. And this 4-question framework was proposed by Adam Shostak when he was with Microsoft, so at least a decade back. He's now an independent contractor or an independent consultant, or he owns his own company. He's no longer with Microsoft, but this 4-question framework has become so popular that every book, he wrote a book as well, and there are many articles around threat modeling in general. Generally speaking, threat modeling is an advanced topic, but if you think about what are we developing or what are we working on, and what could go wrong as a second question, and what are we going to do about it, and did we do a good job to make sure that we close the loop or not in mitigating those risks. That is all about threat modeling. So there are only 4 questions to think about. What are we building, or what are we working on, or what has been already built? Sometimes threat modeling is done after the system has been built, unfortunately, because organizations don't have a structured way of threat modeling um, until recently, but the legacy system has been in place for last 10 years, right? So ideally, a threat modeling exercise must be done during the design phase before you build the system, to identify what could go wrong and what are we going to do about it, and make sure those controls are in place, or make sure those mitigations are in place, and validate whether we did a good job or not. But sometimes many times actually, we take a legacy system and perform threat modeling on the legacy system which already exists, and then think about what potential threats exist for such an architecture, if it is an internet facing web application or internal facing database or whatever it is, and then identify potential gaps, analyze the vulnerabilities, and see if the risk is minimal, or risk is high, and then come up with the controls to reduce the risk, aligning to the risk appetite. Again, any question? If you have any questions, unmute yourself and ask a question. Otherwise, type it in the chat window. So threat modeling, many people even in the industry, after 4, 5 years, 10 years, they use the words threat, vulnerability, risk interchangeably. They're all different. They mean different things. Okay, so some people even use the words information security and data privacy interchangeably. They're different, as you guys know. So threat modeling, threat intelligence, they're all different aspects of the security operations, right? Threat modeling is more aligned with the security architecture, more aligned with the proactive security. Threat intel or threat intelligence is more aligned with the reactive security or operations. So one is on the architecture side, the other one is on the operations side. So NIST's cybersecurity framework, I think in 1.1 called out about the risk. NIST CSF has gone through many iterations. The latest one is 2.0. I started with 1.0, then 1.1 and 2.0. I think right from the beginning, if not from 1.0, but definitely there in 1.1, identifying the threats, internal and external, has been one of the key elements of NIST cybersecurity framework, CSF, in the identify area. Okay, so you identify threats or vulnerability as part of risk assessments, and sometimes it is after the system is built, you may come up across potential threats when it as part of threat intelligence but threat modeling is mainly around a structured and repeatable way of identifying threats before the system is built as part of the design phase. So I was saying, I think I just mentioned this, threat modeling aligns more with the architecture and design portion of SDL, secure development lifecycle, whereas threat intelligence is aligned with the operations as reactive security. But both are mapped to the same line item in the NIST CSF, cybersecurity framework, which is identify, risk assessment, threats are identified and documented. Okay. Just in case if you're familiar with CSF. If you're not familiar with CSF, you can ignore what I just said. But just focus. Let's focus on threat modeling. The next few slides are very, very basic to understand threat modeling exercise. Okay, so if you do not understand the cloud controls matrix controls that I'm going to discuss after this threat modeling primer, you can always pick it up later, right? But because there's no one control framework, there's no one risk management framework. There are many. NIST CSF is one, ISO 27000 was another one. CCM is more specific with cloud controls matrix. That's why I selected the CCM for this presentation. But in general, no matter what the framework is, the threat classification is the same. It doesn't change. It's called STRIDE. You might have heard this already, and it's not new. It's been around at least 10 years. Microsoft came up with this, as I was saying, Adam Shostak and his team members at the time, way before 2014, they came up with this acronym: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. That's what STRIDE stands for. And this is a busy slide. It has a table and explaining the definition. Some of these words like information disclosure is straightforward to understand. It's self-explanatory what information disclosure means, right? Denial of service is also mostly self-explanatory. So which is basically forcing a service to degrade or deny or make it unavailable. If you go to, if there is a denial of service attack on Zoom, right? So on Zoom service is not available, we won't be able to have this discussion or this meeting today. Spoofing is acting as someone else. If I know your password, basically I log in as your username, your password, or your credentials. So I am spoofing you. That's what spoofing means. Pretending to be another user or another process or another system. Because it's not always a human actors. There are non-human actors as well who are authenticated, like a web service client or RESTful client or API client that want to talk to an API to retrieve data or to post data. So elevation of privilege is basically pretend you are authenticated as yourself, but you're trying to take additional privileges that you're not authorized to. Okay, so that's a threat, and obviously the mitigation is to enforce strong authorization. To mitigate spoofing threat, the mitigation is to enforce strong authentication, whereas for to mitigate elevation of privilege threat, the mitigation is to enforce strong authorization. Okay, to enforce the principle of least privilege. So those are the six threat classifications or six kinds of threats. The acronym is STRIDE, right? You remember that? And then there are four types of threat modeling elements: actor, human, or typically human, but the API client is an actor too. A data store, easy to understand. Anything which stores data, databases, file systems. LDAP is not really RDBMS, but it is a data store. Cookies, memory cache, anything which holds data is you can think of as a data store here. Data flow, over a network protocol, whether it is TCP or IP or HTTPS or UDP, whatever it is, right? So data flowing from one component to the other component, or one actor to a web service or web server, or web server to an application server, or an application server to a database server. So anything which flows, called data flow when it comes to threat modeling elements. And if it is not an actor, if it is not a data store, and if it's not a data flow, then it's a process. Okay, so typically a process runs code. Web application is a process. Web server is also a process. Application server is a process. Okay, so operating system is a process. Anything which is not an actor or not a data store or not a data flow is a process. That's how to remember. So there are 4 threat modeling elements, and there are 6 threat classifications. So that's all put in a matrix called stride applicability to threat modeling elements. So an actor could be spoofed, okay, and some of these threats do not apply to, not all the threats apply to all the threat modeling elements. So you remember so even the advanced threat modelers keep this matrix handy before they think about what threats could apply to their architecture diagram or to their system that they're designing. Okay, so when you're thinking about a customer or an employee or an admin or a regular user or any human actor, you think about 2 threats: spoofing and repudiation. That means a person may log in into an application and may say, hey, I did not log in. A person may walk into a room like this is a meeting room, right? Or a high sensitive lab, and may claim that they did not enter the lab or did not enter these, Zoom meeting, for example. As long as there is a way to log it and prove it that a person did access a resource, whether it's a meeting room or a high sensitive lab, that threat could be mitigated. So, I mean, this matrix is self-explanatory. That means that all the 6 threads apply to process. 4 of these threads, which is tampering to denial of service, apply to data store, and three threads apply to data flow. Okay, so for the purpose of today's this 1-hour meeting, think about this something which people needs to keep it as handy when they're thinking about threat modeling a system that they're designing or planning to build. Okay, so that ends the threat modeling primer, right? So what did we learn? There are 6 threat classifications with an acronym STRIDE: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege, right? There are 6 threat classifications. There are 4 threat modeling elements, and there's a matrix that all the threats do not apply to all the threat modeling elements. Some threats apply to the specific threat modeling element, whereas all the 6 apply to process. So now we are going to talk about the controls, the other side. So we talked about threats, and now we need to talk about the controls which are used to mitigate those threats and reduce our risk, right? So this is where you can have multiple frameworks, NIST, CSF, ISO 27000. There's so many risk management frameworks. There are so many security control frameworks like CSF, as I said, RMF, so on and so forth. Before I go to CSA's Cloud Controls Matrix, which has about 192 controls, security controls, divided into I think multiple domains, like 15, 17 domains. And the matrix shows which threat applies to which cloud service model, like software as a service, platform as a service, or infrastructure as a service. I hope that all of you know those 3 service models of a cloud. It's been around for at least 15 years. NIST defined this at least in 2006 or even before that, around that time frame. We are going to use all that. That's why this session is called Threat Modeling Cloud Services, not threat modeling any system. Okay. So before I go there, I'm going to talk about shared responsibility model of cloud in a cloud, right? In a cloud model. So cloud consumer, for example, right now we're all cloud consumers. We are using Zoom, which is a software service. Okay, it's running on Zoom Cloud, which is a cloud provider. Okay, it's a software as a service provider. Zoom software as a service may be running on AWS infrastructure service, AWS infrastructure, which is an IaaS provider. If you're familiar with Force.com or Salesforce, which is a platform as a service, Salesforce provides both software as a service and platform as a service. You can develop code on Force.com platform, which may in turn be running on AWS IaaS model. Okay, so regardless of which cloud provider or cloud consumer you're talking about, this matrix here, right, where it shows infrastructure service, platform as a service, SaaS, which is software service, and there are these five rows here: security, governance, risk, and compliance on the top layer, data security, application security, platform security, infrastructure security. You see that who is responsible for the security of which layer. Okay, which means that let me walk you through this. In case of infrastructure, if a cloud consumer is using infrastructure service model, most of the responsibility lies with the cloud consumer. That means the cloud consumer is responsible for security, governance, compliance, data security, application security, platform security. Whereas when it comes to infrastructure security, it's a shared responsibility. Let's take AWS or Azure as a IaaS provider. AWS will take care of the data center security, the building security, the power and all that stuff, and to the extent of network security. But there are controls which are provided to the cloud consumer to manipulate those network level security, which means that it becomes shared responsibility. Now move to the extreme right, like Zoom or Google Mail or Microsoft Mail or whatever, right? Hotmail. In the SaaS model, right? We are cloud consumers of Zoom, but we are not really uh, responsible for the security of at the network level, how the Zoom service is running, or the platform level, right? But definitely we are controlling who can enter the room, right? We have the privilege to control who can enter the room. We can mute them. So that's called that can be tied to the application security or the privileges. Who is the hook? Who is the host? Who is the guest? Who is co-host? Who can speak at any point of time, or who can share their video, so on and so forth. Who can share their screen, so on and so forth. So that can be controlled by the cloud consumer. But regardless, the once the video is recorded, and that data security of that video is entirely the responsible to the cloud consumer, and of course the risk and compliance is the responsible to cloud consumer. So if you know the shared responsibility model is very, very important and very relevant in the cloud deployment service models. So I hope you know the difference between cloud deployment models and cloud service models. So these are the three cloud service models: software as a service, platform as a service, infrastructure as a service. Whereas deployment models are public cloud, private cloud, hybrid cloud, community cloud. So we're not going to talk about deployment models here. The reason why I'm stressing that this is so important is that every cloud provider has got their own shared responsibility model. So the previous one is provider agnostic. It doesn't matter, right? Which cloud it doesn't. I didn't say whether it is AWS or Azure, right? I've just talked about IaaS or SaaS or PaaS. This is the shared responsibility from AWS. Okay, again, busy slide. You don't need to spend too much time here, but this is the link if you want to take a look at it later. Azure has got its own different service, different shared responsibility model based on their services, based on their service model of all the three services that they provide. Okay, Google has got its own their own shared responsibility model. Okay, so the reason why I spend so much time on explaining the shared responsibility model for cloud is because that's basic to understand cloud controls matrix from Cloud Security Alliance CSA. So I was saying, again, this is V4, okay? I think we are still in V4. I don't think CCM V5 was released, but there might be a minor version released later after this slide. As I was saying, there are 17 domains called CCM domains. There are total 197 controls. In NIST CSA 1.1, there were like, I think 110 or 120 controls. In CSF 1.0, there were 99 controls. ISO 27000 has a lot more controls. But here, these domains and these controls are very, very relevant to cloud service models. Okay, whereas CSF is not just for cloud; it's for any general IT system or any software application, any IT system, basically not necessarily limited to the cloud. So definitely CCM is more applicable when you're threat modeling cloud services and understanding the shared responsibility model, understanding the threat classification, understanding the threat modeling elements, and the crosswalk between that threat classification or threats, straight framework, and the CCM controls. So again, it's busy slide. There's a lot of information here. If you haven't already seen it, you can download the CCM for free. There's a CCM Excel spreadsheet as well as a PDF explaining these controls. I'm going to share that anyways in a few minutes. So if you look at CCM's cloud controls metric, I shared three shared responsibility model, one from AWS, one from Google, one from Azure, right? So if you look at the 197 controls, you see in IaaS model, cloud consumer, so in our case, in this during this hour, we are the cloud consumers of Zoom service. Cloud consumer is responsible for 16 controls. Okay. In an IaaS model, let's say if we are using AWS IaaS service or Azure IaaS service or Google GCP, okay, cloud consumer is responsible for 31 controls. The number doesn't matter. The concept is important. That means that if you are a IaaS consumer, you are responsible for implementing more controls. Okay. If you are a SaaS consumer, you're responsible for less number of controls because the cloud provider is responsible for more number of controls. Okay, enforcing those, making sure, and there of course there is always the shared controls. There are areas where you need to understand the shared responsibility to make sure that the provider does their part and consumer does their part to mitigate those risks. Okay, so just to give you an example, this screenshot is from the CCM controls metrics 4.0.8. I was saying there might be a minor version released after that of that version, but the concept is still the same. There is this control domain called logging and monitoring. The control title, those are the actual controls, and there is a control ID, right? Log 1 to log 5 in this screenshot, and there's a description of this control, but it's busy slide, you probably don't need to read that, but you can just think about logging and monitoring as a policy and procedure, or enforcing those logs. So if you're developing a IaaS service, a service which is going to be deployed on IaaS model. Okay, so if you're developing an application or whatever you call it, a platform or a system on AWS IaaS or Azure IaaS or Google IaaS like GCP, then let's take log 03. So this is cloud consumer. CSC stands for cloud consumer. CSP stands for provider. Okay, so in IaaS model, consumer is responsible for that. Owned means responsible. Okay, in PaaS it is shared, whereas in SaaS, provider owned. Okay, so you just need to understand the concept where the cloud consumer is responsible for a control, where the cloud provider is responsible, and where it is shared responsibility. Okay. So why I spend so much of time explaining the shared response model is basically understanding that is crucial for threat modeling cloud services. If you're just developing an application in your data center or which is going to run just in your lab, you are responsible for all the threats. You're responsible to mitigate all the applicable threats. Whereas if you're developing a cloud-based service, whether it's a service which is going to run on force.com platform, where you're developing code, but you're not responsible for OS level, the provider is responsible for the security of operating system, whereas you're responsible for developing secure code and deployment and all that. It's very important to understand that shared responsibility model for effective threat modeling of cloud-based services. Okay, now we are going back to tying up these two. The left-hand side are threats, which is stride framework, and the right-hand side is the controls from CCM. Okay, so and I kind of mentioned this verbally, that to mitigate the threats related to spoofing, the risk mitigation is enforcing strong authentication. Strong authentication is enforcing strong passwords, like 14-character passwords or whatever the CSF standard is, or you can implement multi-factor authentication, where something which you know and which the user has and user knows. I mean, multi-factor could be two-factor authentication or three-factor authentication, depending on it. And what really matters is you don't want to implement too much of security, because implementing security is expensive. You don't want to implement three-factor authentication when the data is not very sensitive, right? But if the data is sensitive enough, you want to implement at least two-factor authentication instead of one-factor passwords. Even though there could be 14-character passwords, that's less. You don't consider that as strong authentication compared to two-factor authentication, because something which you know and which you have, it gives you additional authentication or strength of authentication. So the tampering, data tampering, application tampering. If you're familiar with SQL injection or parameter injection or cross-site scripting, so of web applications, so that falls under tampering. If you can manipulate a web application behavior based on what you write in a text field or a text area of a web application, then that is called tampering of that application. So the mitigation is protecting data integrity by using strong cryptography. I just gave sample controls there. Okay, just to showcase that for one threat, sometimes you just need one control to mitigate that one threat. Okay, so in case of spoofing, in the first line here, I don't know if you can see my mouse here, mouse movement. So you just need one control called IAM14, strong authentication. Whereas here, to mitigate one threat by denial of service, you may need multiple controls from the framework. Okay, in this case, BCR 0, 6, 10, and 11. Okay, you may also notice that one control may mitigate multiple threats. You see this data encryption and key management. If you implement those controls, it mitigates both tampering and information disclosure. So strong cryptography controls mitigates both data and tampering threat as well as data disclosure threat. Okay, so it's a many-to-many relationship between the threats and the controls. Okay, so it really depends on your system. You may need, depending on what the threat is and if the threat is real or not, if the threat applicable to your system or not, is it a shared responsibility model, if it is a provider responsibility or the consumer responsibility, cloud provider and cloud consumer responsibility, you may need to implement one or more controls to mitigate that. And if you implement one control, it may mitigate more than one threat. Okay, so there's a many-to-many relationship between threats and controls. Okay, so I think we are doing great on time. We are at 10:35. We still have 25 more minutes. I'm going to provide a demo right now. But before that, I want you to understand using the spreadsheet that I'm going to share, a tool that I developed, which it's free for you guys to take a look at it or download it from the URL that I'm going to provide, and make it your own, and you can use it with any framework. You need to understand there are 6 steps, okay, to effectively use the spreadsheet-based threat modeling tool for the cloud-based services. In fact, it doesn't matter whether it's cloud-based service or not. For any IT system threat modeling, using this spreadsheet that I'm going to share, there are 6 steps. Okay, so the first thing is, remember those 4 questions: what are we doing, or what are we working on? What could go wrong? What are we going to do about it? And 4th question is, did we do a good job? Right. So here, based on those 4 questions, what are we working on? Create an architecture diagram and label the artifacts. Like here, let's look at the SAS service here at the bottom of the right hand side, because that's the easiest one to understand. That's what I'm going to walk you through this, because that's the easiest one, and of course you can just build upon those for the PAS and IIS later. So in this particular case, let's say you're using a Gmail service. Okay, Gmail is a SaaS service that Google offers, and all you do is use a browser or a mobile client, or a client email client to access your email, right? So there is a user, that's you, right? An actor, because everything needs to be one of those 4 threat modeling elements. Let's take a browser. Someone tries to access mail.google.com. So that goes to the mail server on Google side, which is a SaaS service. So there are only 3 artifacts in this particular model, SaaS model: a user or an actor, a data flow that the data goes and comes back, right? When you click on a particular link of an email, you get the contents of that email. But you don't really need to understand how that SaaS service works, right? You don't need to know what operating system the system is running on, how many nodes are there, what kind of database the data is stored, what kind of file system. You don't need to know any of that. If you're threat modeling a SaaS service, whether it is a Salesforce application, which is a SaaS version, or a Workday, or any, there are hundreds of SaaS services. Every enterprise uses hundreds of SaaS services. When you're threat modeling, all you need to worry about is an actor, data flow, and the process of SaaS service. You don't really need to understand the mechanics behind that. Okay, so that's what the first step is: create an architecture diagram and label the artifacts. And of course, I'm going to show the spreadsheet. What I mean by list down each architectural component, identify and assign potential threats from the stride applicability matrix that I showed you before. Not all the threats apply to all the threat modeling elements, but all the threats apply to process. Describe threat, provide threat description in plain English, and propose the risk mitigation plan, right? What is risk mitigation plan? Implementing security controls. That's all it means, right? And to think about how to you first think in generally outside the framework. Strong authentication is what you think about to thwart spoofing. Now, how do you implement the strong authentication, and how do you identify the exact security control is the 6th step. Okay, that's the last step. Okay, I'm going to move this here. Hopefully you can, do you see my screen?
Yes, we're able to see your Google sheet.
Okay. Let me go here back. So this is the link which you can, once I share this slide deck, you can always go to that link and download this this Google Sheet as an Excel or whatever, right? Or you can ask me permissions, and I'll be able to provide the permissions. It should be open anyways. Okay, so whatever you've seen in the slide deck, right? You can still see the screen, right? The Excel.
Yes, we can still see that.
I just described here because I want to make this independent of the slide deck. So basically, what is threat modeling? Threat modeling is structured and repeatable process to identify threats and mitigations. There are 6 steps to create a threat model, and those 6 steps are mapped to the 4 questions. What are we working on? What can go wrong? And what are we going to do good? And did we do a good job? And these are the 6 steps that I just described in the slide. So these, and pretty sure you remember this graphic. And the next worksheet or tab here shows the 6 threat classifications, 4 threat modeling elements, and 197 security controls from the CSA CCM. Okay, so which are divided into 17 domains, right? You can see there are 197 security controls and the 3 architecture diagrams, which I showed you in the previous slide. But for the next 20 minutes or 15 minutes, we'll just focus on threat modeling a SaaS application because it's the easiest one, and there are only 3 elements, right? Actor, data flow, and process. But if time permits, we can go to the PaaS model, which has 5 elements, and IS model, which has 7 elements. Even then, these are the simplest architecture diagrams that you can think of. The real architecture diagrams of a complex system, you could have 20 components, right? 50 components. Depends on really how complicated or how many integrations you have on that server, on that system. Okay, so this is the meat of the tool, right? This is where you see, this is where you perform the threat modeling, okay? So the first 2 columns here is analyzing the model, right? Understanding the architecture diagram, identifying the artifacts, labeling them. So as you can see here, 1 here means 1 here, okay? And 2 here means 2 here, and obviously 3 here signifies the SaaS service here, okay? But anyway, before that, think about column A and B as analyzing the model. That means artifact depicting the architecture diagram and what is the corresponding threat modeling elements, whether it's an actor or a data flow or a process or a data store. There are only 4 threat modeling elements, which is a drop down here. You can select one of those, right? And then there are 6 threat modeling threat classifications, which are spoofing, tampering, repudiation, so on and so forth, which is a drop down, which is what you use in the next step, which is identifying threats. So for an actor, so first of all, before an actor, you'll think about what is the who is this person or this in the architecture diagram. It's an employee. It's a human user. Sometimes it's an API client. It could be an email client. Okay, but even the email client needs to authenticate to the service. So you identify whether the first artifact or artifact number 1 is an actor or a data store or data flow or data process, and go back to that the matrix, right? Let me make sure that I go back here. This matrix, okay? So based on this matrix, there are 2 threats that apply to actors, spoofing and repudiation. So you basically need 2 line elements because there are 2 threats that apply to this threat modeling element. And think about what are the threats, that is spoofing and repudiation. For spoofing, so the column E2, E, F, G, H, whatever, right? The next several columns is about thinking about how do you mitigate those threats by implementing the relevant controls. In this particular case, all I need is 1 control, which is strong authentication, IAM14, which I showed you in the previous, which is MFA. Okay, you won't know IAM14 is strong authentication unless you know the framework, right? So if you're already familiar with CCM framework, then you would know. Otherwise, you wouldn't know. You need to go back and look at what are the controls that provide strong authentication. And as you can see, this is a drop down of 197 controls, right? So there are 3 drop downs. All the 3 drop downs are coming from these lookup values here that I showed you, which means that once you make this tool your own, you could replace CCM controls with NIST CSF controls or ISO 27000 controls or PCI DSS control, whatever the controls that are relevant to your system, okay, or to your organization, or it could be your own standard, right? Every company has got their own standard, security standard. Cisco has got their own security standard. IBM has got their own security standard. Red Hat has got their own security standard. And it could be 30 controls versus 197 controls of CCM. Okay. And let's say for a particular threat that you can think of, there is no control at all that you could use from the selected stand framework that you're supposed to use. So from out of 197 controls, if there's not even a single control which could be used to mitigate the threat, you just basically write that control in a free text form, right? Just in English, plain English text. If the CCM controls are not relevant to organization, just type that, right? Whatever it is, okay? So that means that to mitigate one threat, you could have one control, 3 controls, 2 controls, or 0 controls from your framework and just come up with a free form English text. This is how we are going to mitigate, or we just accept the risk. Okay, there's no way to mitigate this risk or this threat, and hence we accept the risk. Okay, so once you understand how this tool helps you to threat model, it's just a matter of applying the same logic for all kinds of threat modeling elements, whether it's a data flow. Now, when in this architecture diagram, number 2 is data flow, right? From the actor to the process. That is what these 3 line elements are, because for a data flow, you have three applicable controls, which is tampering, information disclosure, and denial of service. Okay, so now you go back here, tampering, information disclosure, and denial of service, right? Which is, again, they're all drop downs if you want to change those, right? If you disagree with this, you just change what applicable threats for that particular data flow or for that threat modeling element is, and you come up with your own threat descriptions in plain English, right? So as you can see, column C is a drop down, column B is a drop down, column D is not a drop down. You just type whatever you want to write to communicate those threads to your team members or to yourself, right? Because at some point you're going to look at this, understanding your own threat model. And if you don't understand your own threat model, that is just it's like, if you don't understand your own code. So you may want to explain as much as possible what the threat description is, and then column E to E, F, G, whatever it is, they're all drop downs from the controls. Okay, so there are three drop downs which are from that lookup values. In summary, right? Unless you guys have any questions, I'm going to summarize everything that I explained, how to do threat modeling, cloud services, right? There are 6 steps. Okay, one is to come up with an architecture diagram, which is an example like this, and label these artifacts. Actor is number 1 here, data flow is number 2, process is number 3. In here, 2 is a data flow between an actor and a CRM application. Number 4 is a data flow between CRM application to a database. In this architecture diagram, number 6 is a data flow as well from an application to a SQL database. Okay, so no matter what it is, you come up with those architecture diagram and label the artifacts, right? And write that in the column A. Okay, describing in plain English what that artifact is and the number is, and identify the threat modeling element. There are only 4 threat modeling elements if in the Stride framework. If there is no choice, you have to use one of these 4, whether it is an actor or a data store or a data flow. And if it is not any of these 3, then it's a process. Then use the matrix, right? The Stride applicability threat modeling elements matrix to identify which threats apply. The template already has those, right? If you want to, change that for whatever reason, you may, but you don't need to. Actor has 2 2 applicable threats. Process has all the 6. So let's talk about SaaS service, right? SaaS service has all the 6 threats: spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privilege. In case of SaaS services, we talked about this. We don't have any control on OS. We don't have control on what type of databases the SaaS service provider provides. So now, how do you mitigate the threats? What does threat modeling means for a SaaS service? It's called vendor risk assessment, or third-party vendor risk assessment, or cloud service risk assessment, whatever. There are many different names used in different organizations. In CCM, it's called STA 09, primary service and contractual agreement with the particular service, whether it's Google or Zoom in this case. Okay. And in some cases, the cloud provider allows you to do pen testing. Salesforce doesn't, big providers doesn't allow you. They just provide you the the pen testing report that they got it performed through their own provider, through a third-party provider, their third-party provider. But some small SaaS vendors, they allow you to do the pen testing. So if they allow you, then you're basically going to write this one here. Pen testing is a control from the CCM, TVM 06. TVM stands for third-party vendor management. Application vulnerability remediation. Let's say if you did find vulnerabilities based on your own pen testing, or if you find open vulnerabilities from the pen testing report that the cloud provider provides, you make sure the provider closes those threads. We do that all the time. We do not sign the contract until all the threats that are identified in the pen testing report are closed or mitigated. Sometimes, as I said, Salesforce doesn't allow you, in which case you just, blank them out. You're relying on the contractual agreement. Okay, you're just relying on the due diligence and you're not enforcing any additional controls. Okay. Let's talk about this. Information disclosure. Okay. So this is SaaS service. And if you're worried about the sensitive data that is stored on the SaaS service, might be, subject to data breach or information disclosure threat is real, right? Through however way, whatever the mechanism is to that the data is breached or the information is disclosed. So you rely on the contractual agreement, right, as a minimum because the SaaS service. And also sometimes you enforce, not all the providers provide, but some providers provide you to enforce or specify how the data is encrypted, and even the keys or who manages the keys. Like Slack, for example, or Salesforce provide, or all the big players provide cloud consumer managed key management. Okay, that's more involved. But that's in your control, right? So depending on situation, the cloud consumers may opt for consumer managed keys, especially enforced in some companies by legal departments, that we don't want the key management or keys are managed by the AWS cloud provider. Okay, we want to manage the keys. And if that capability is not provided, then they say that we encrypt the data, cloud provider encrypts the data, and they manage the keys, then you do not have this control. But if they provide cloud consumer managed key capability, then you select that as the mitigation factor. Okay. The last one is elevation of privilege. The control is enforcing the principle of least privilege in addition to the contractual agreement. But in reality, it's a very involved process depending on how complicated the application is. In some cases, it is basically RBAC, role-based access control. There are only 2 or 3 roles in an application, and you provide read-write access or whatever, administrative access or super user access. But in an application like Salesforce, even if it is a SaaS application or a PaaS application, there could be hundreds of permissions, and it gets really complicated to enforce principle of least privilege. Okay, but that's the mitigation. Right? From the threat modeling perspective, that's where you end it as threat model, because defining the scope of the threat model is important. And now we need to go back and see, did we do a good job? That's what the, once you mitigate or you come up with these ideas to mitigate those threats, and you need to validate whether those controls are in place for all those hundreds of permissions in the previous example. So we have just 4 more minutes. I don't know if there are any questions at this point. Were there any questions typed in the Zoom chat window?
It does not look like we've had any questions coming in.
Okay. Just want to leave you with another link here, assuming you can see. Whatever I explained, it was also recorded elsewhere using NIST CSF, not CCM, that is NIST CSF. And this is on threatmodelingconnect.com. I'm one of the founding members of this online community called threatmodelingconnect.com. And about a year back, I explained the same thing what did I explained you, which you can take a look at it. And there are, of course, many other articles and there are many other videos that are uploaded to Threat Modeling Connect by various practitioners, threat modeling practitioners. And this template focus on NIST CSF, whereas what I showed you is focus on CCM, which means that this model or this template could be used with any security framework, any security standard for or any control framework. Okay, so see one comment. I see. So the website requires login. Is that for the Threat Modeling Connect? Okay. So you may need to, yeah, you need to you need to be a member of Threat Modeling Connect, if that's what you're referring to. It's a free membership, so you can just go and create your own profile, user profile, or log in using Google or social auth, and then you can access any of these resources that are available there. It's been more than a year old now, so there are many resources. There are 4 guides, 14 recordings, 20 blogs, and some presentation from Threat Mod Connect. Any other questions or comments? Hopefully that was useful. Hopefully it is not too complex or too advanced for you guys. If you have any questions about any part of this today's presentation, either contact me on LinkedIn or reach out to me through Professor Brenda. I'm going to stop sharing.
Hey, Dr. Shibrelu, this is Craig Jeter. I just want to say thank you for really taking the time out of your day to speak to students. We greatly appreciate it, and thank you for just sharing your expertise on it. Again, everyone, please make sure to connect with Dr. Shibrelu on LinkedIn, like you said. I'll make sure to send out your LinkedIn information to our members. Also, be on the lookout for a couple updates regarding those who are graduating. And yeah, that's about it. Again, thank you so much, Dr. Shibrelu, and I hope everyone has a great day.
You too. Thank you.